We're in Module 5 for the technician class, and tonight we're going to cover modulation, transmitters and receivers, digital communications, power supplies, and batteries. So next. Okay, you've seen this picture before. This is your typical transceiver. You have a transmitter, receiver, and the TR switch is all in that box. Power supplies are usually external, although there are a few older radios that do have a power supply in them, and they get a little bit heavy because they're old. The power supplies were analog, which means they've got a transformer in them. Next. Okay, that's what a real one looks like. That's my radio sitting right here on my right hand. You got the computer sitting there on the left. Bottom is the tuner, which is not in that previous slide. The next thing up is the radio itself. It's got the white screen, and right there I'm working FT8 on 17 meters. Right above that is the power supply, and if notice the size of some of this stuff. It is not very large, and that little white box up at the top, you remember what they call that? We'll get to it. A multiple protocol controller, the MPC. Never heard of that till I read this lesson. That little box basically takes the audio out of the radio and connects it to the laptop, which this particular one is connected to the sound card in the laptop. And it also handles the push to talk to tell the radio when to transmit. But that's what that diagram you just saw turns into in the hardware. Okay, next. What happens during radio communications? We transmit, that's sending your signal. You have information, voice, data, video commands, etc., and that is converted to an electronic form. The information in the electronic form is added to a radio wave. Okay, that radio wave carrying the information is sent from your station or the other station antenna into space. All right, keep going. The other side of it, receiving. Radio waves carry that information through the air, and when that radio wave intercepts your antenna, next one, your antenna sends that electrical signal down to your radio, which extracts the information from the received wave. Oh, I really like some of their words here. The information is then presented to the user in a format that can be understood. Sound, picture, words on a computer screen, response to a command. You saw in my previous station with the computer sitting there, that computer screen showed the software running that program, and the information that was the information that it extracted from the radio signal. That's what you saw on the computer screen. If you were listening to an AM station, then you hear voices, music, and things like that. So, okay, let's keep on seeing what happens, Howard. Okay, adding and extracting the information can be simple or complex, okay? And guess what? They say that makes radio fun. Learning is all about how it works, okay? Don't be intimidated. I think I've said this before. Don't be intimidated. In this test that you're going to take, you're only going to be required to know the basics, but you can learn as much about the art and science of radio as you want. And believe it or not, there's more art in this than you might ordinarily think. Okay, adding that information is modulation. So when we add some information to the radio wave or the carrier, we modulate the wave. Okay, turn it on and off. That's Morse code. We can add speech to it. We can add data to it. Okay. Different modulation techniques vary different properties of the wave to add information. And those three basic ways are amplitude, frequency, or phase. Okay. A signal that doesn't carry any information is called unmodulated. Recovering the information from a modulated signal is called demodulation. Back in the old days, before Howard and I were born, they called it a detector. Okay, here is your waves. I think click the next one up, Howard. Okay, information can be added. The simplest wave, you see the continuous wave up there at the top. Keep going. Okay, Morse code, that next thing down there, you're turning that wave on and off. That's what that dot and the dash, you have a short one and a long one. That's information. Okay, amplitude modulation, you use the information that you're putting on that carrier to shape or modulate its amplitude. That's why they call it AM or amplitude. Next. Keep going. Okay, the information is contained in that envelope. That's the shape of the amplitude. That's what your radio does when it demodulates that signal. Okay, next. There's my detector word. Recovering speech or music from the envelope of an AM signal is called detection. Okay. Composite signals or sidebands. Next one. In an AM signal, there are actually three separate signals. You have the carrier, which is that 800 kilohertz spike in the middle, and then you have the two sidebands, one on each side of that carrier. One is the sum, and the other is the difference in the signals with the carrier. Don't worry about that. Just remember the word sidebands. Okay, that carrier is a steady, unmodulated signal. Next. Then that upper sideband is, and that's the one on the right, is the higher of the frequency than the carrier. That's where you added to it. The lower sideband, which is the left one, is a lower frequency, and that's where you have subtracted the information or the frequencies from the carrier frequency. Just remember upper and lower sidebands, okay? In an AM signal, the carrier doesn't carry any information, okay? Each sideband contains a copy of the modulating signal, okay? Only one sideband is needed to transmit the information. All of the single sideband or SSB signal power is concentrated in the one sideband. Remember these next words. Single sideband signals are effective for long distance and weak signal voice contacts because of the additional power. Remember that when you'll see it again. The upper sideband is used on VHF and UHF. Both upper and lower sideband are used on the medium and high frequency or HF bands. Okay, frequency and phase modulation.
You want to look at the AM stuff first, or?
Let's do that.
Okay, hold on a second. Let's see, I got there it looks like. It's working good yesterday, didn't it?
Yeah, it worked real good when we practiced. What happened?
Well, let me back up here twice.
Well, while we're waiting, I have an announcement to make. Well, let me back up. Benson, you want to make that announcement, what happened last Friday, or you want me to do it?
I'll go ahead and let you do it.
Okay. Well, folks, Benson come in to Ingalls this past Friday and tested. He passed his tech, only missed one. Then he took his general. He aced his general. So as of now, he went to no license to a general class ham radio operator. Congratulations, Benson.
Well, congratulations, Benson.
Thank you.
And his call sign is Kilo Quebec 4 Hotel Lima Zulu.
What stopped you from going for the extra?
I showed him the exam. He got scared.
That's a whole nother ball of yarn.
Yep.
But
yeah,
seriously,
I had to turn that overlay upside down to get him to miss any.
yeah. But seriously, he'd aced both of them, but he changed one of the answers on his tech, and he had it right, but changed it. So
Yeah.
just a warning to everybody: when you take your test, don't change none of your answers, because 90% of the time the first answer is correct.
Okay, you gonna tell them what we're looking at, Howard?
Yes, but would you believe that it appears that 570 is off the air, or I've lost an antenna one? I wouldn't have thought that would happen, you know?
Well, every now and then, for reasons that nobody's ever explained, they go off the air for some short period of time.
I heard
But I'm a little bit curious as why you're not seeing a carrier, because what happens is whatever they're doing finishes before the next thing, and this is all, I think, computer controlled. There's not somebody there, doing this all the time. Is whatever it was finished, and is going to be a up to 30-second bit of silence, and then all of a sudden the weather or the news or traffic report or whatever's happening next comes on. But I'm not.
Let me just move up and find another good strong
Yeah,
station.
go down to the bottom end of the AM band. I know there's.
Well,
There we go. That's a good one.
All right, this is an AM signal. Let me get it tuned in perfectly here.
And what he's got highlighted in the upper left is that lower sideband.
And let me go ahead and move this thing to AM. Oops. I don't know where I came up with that. And And when I did, it changed the frequency on me. I do not understand. Let me go back down here and get that strong. What we're looking at is my wind radio receiver. Across the bottom is the spectrum from 0 to 30 megahertz. And that's all the signals that I'm receiving between 0 and 30 megahertz right now. In the top left-hand corner is the frequency that we're looking at. And what I have the pointer right now is one of those AM signals like they had drawn. And if we come over here on the right-hand side, that is just a larger picture of the same station. And I don't know why we're not hearing some audio. Well, I guess that mute sign right there probably has something to do
Yeah,
with it.
you got your mute button turned on. There we go.
Hunt Brothers Pizza, the official pizza of Carolina.
Now, if you can see right in the middle there at the top, that spike that's sticking up and isn't changing, that is the carrier for that AM station.
20 years. With all toppings, no extra charge, and 10 to choose from, there's sure to be a topping combination for everyone to enjoy a Hunt Brothers Pizza.
And I don't know why that sharing
Not a
won't go.
challenge. From gas-powered blowers,
Won't go
chainsaws,
well.
take on almost any outdoor task. To high-performance pressure washers built to tackle your toughest cleaning jobs. Steel has a wide range of outdoor power.
Just when you're practicing the art of radio, this is what happens sometimes.
Find yours at stihldealers.com.
There we go.
Available participating dealers. Adrenaline fuel. Spin, drive, make my move.
The problem is I can't get to the controls that I need to get to.
Light, flash. Then glide back down.
What we were attempting to do was to show you that both the upper and lower sideband contain the same information.
Spirits that play on the course and off-road.
And
Carolina Ford dealer today. Not all models, trims, or features may be available. Contact your dealer for more information.
let me see if I-
Have you been injured in an auto accident and need to know your rights? Dial 919 all fours.
What happens if you click the lower sideband button? Does it take you back to the other frequency?
Well, what I'm doing is
all fours.
I couldn't get to that lower sideband button.
Dial
Ah.
919 all fours. Have you been injured by
But
prescribed medication?
by minimizing it like this, we can see it a little better.
Okay, yeah.
Call Hardison and Cochran.
Now, if we go to lower sideband, and I unmute again,
Hey, psst. Yeah, you want to buy some low-price
see, we can hear everything that's there.
Well, Lidl grocery store. Here at Lidl, we buy in bulk and cut
And if
down.
we go to upper sideband,
Then we pass the savings on to you. Trust me, everything's done totally legit and above.
then we're looking at the other side of that signal, and I have to unmute it here.
No grocery store, except with way lower prices.
And you see, you can still hear it.
Suspiciously low price groceries.
But see how much, if you look at the difference, the white highlighted portion here is our filter that's showing us how much of that signal we're actually receiving. And you'll see that the difference between AM and sideband is it's right at half of the amount that you're receiving. And next we'll go to and let me find one here. Now that is a lower sideband signal,
Yeah.
and that's about the normal width of your standard thing. That's 2.3 kilohertz of a signal.
And the point in the presentation was that all of your power is focused in that one part of that one sideband, whether it's upper or lower, instead of being spread out over twice that much of the band. With some pretty good radios, you could almost have two people working on the same frequency, one on upper and one on lower. And I think somewhere we'll talk about that in a little bit different way, but that's the advantage of using upper and lower sideband.
Plus, you can put twice as many signals on the band because they're half the width.
Yeah.
And let's go to the one more we're going to look at. This was.
Excuse me. What does that mean, twice as many signals? Does that mean twice as many people on the same band?
Yes. Because the signal takes up less space, you can get, and each signal being a person transmitting, you can get more signals in because you're using half the space for your signal. And the other thing we wanted to talk about was one of the things that they will warn you about.
Yeah.
And this is like I say, the normal width, which is 2.3 kilohertz. And what we're looking at right here where this pointer is 14.350 megahertz. The receive frequency is set at 14.349. But if you'll see from here over, that amount of that transmission is outside the handband.
You could receive a nasty note from some of there is a volunteer group that monitors things like that, and this, I don't think this is really serious enough, but if you were really wider than that, you could get a little postcard in the mail saying that you need to check your equipment. It's not going to be an FCC person for this, but technically you are transmitting outside of your frequency privileges. And that's one of the things that we're supposed to warn you. I can't remember where it is in this presentation, but when you talk about the band edge is that dotted line going up in the middle of that gray area. That is the maximum frequency that you can talk on right there. And that's why we're showing you that. That is a good graphical picture of what that means.
Now, if we go up here and move down by 2 kilohertz, all your signal will be inside the band and you will not be illegal.
And if you were running an older radio, especially if it were tube type, you might want to pay real close attention to that, because it's not going to be quite as sharp in its tuning as some of the more modern all transistorized radios. And it's just the technology has improved that much. It's not that that's a bad radio. It's just that we have the ability, instead of having 1 0 to the right of the decimal place, we've got 4 zeros that we can play with. So we can tune closer than we used to. But
and just, I guess, while we're here, I was going to say, we'll just tune the other side.
if you hit the lower sideband button right there, okay, you don't hear them. You could have somebody with the same frequency numbers up there running lower sideband, and they may not interfere with each other.
And there's someone at 13,347 staying just inside the handband.
Well, and he's probably got his He's probably running a modern radio that's got a digital frequency rather than a knob with numbers printed on it. And he sit there and he's sneaking up just as close as he can.
Yep. But that's what we wanted to see. I will close this out and get back to the.
Earlier, she was still stuck at work doing her thing, so gave me a little bit of more time to go unload the dishwasher, make sure I.
Hey, Howard.
Yes.
You might want to mention the fact that if they're transmitting, if somebody's transmitting on upper sideband, you can tune them in using lower sideband, but you won't understand what they're saying.
Yeah.
Back in the early days when single sideband was first implemented, the radio that I had was a Hallicrafter S53A. It was pre-single sideband. And I kept hearing this Donald Duck talking. That was single sideband. This radio did not have the ability to demodulate that signal. I'll use that word again since it was in the presentation. Y'all might want to remember that word later. Okay, frequency and phase modulation. That's your third way. Modes that vary the frequency of the signal to add speech or data information are called frequency modulation or FM. Okay. The frequency of an FM signal varies with the amplitude of the modulating signal. Remember they said that it could be simple or complex. This is the complex one. Phase modulation varies a signal's phase instead of changing its frequency. Or as they say, in other words, very similar to FM. FM is the mode most used by most VHF and UHF repeaters. Because of the way FM receivers work, only one signal can be received at a time, and this is called the capture effect. And if multiple signals are present, only the strongest will be heard in the receiver. If you have two stations of equal power, you're probably not going to understand either one of them. If you have two stations where one of them is stronger than the other one, then you're going to hear a lot of fuzzy background on the strongest one. But the person who has the most power is the one that captures your repeater. The other one just kind of interferes with it a little bit, but you'll still hear it. Okay, bandwidth. A signal can have both a frequency and a strength or amplitude. Signals are spread out over a range of frequencies, and that is called the bandwidth. You can communicate with single sideband over much longer ranges and in poorer conditions than with FM or AM, particularly on the VHF and UHF bands. Remember that line right there. You're going to see it again. For even better range, extremely narrow CW signals are the easiest for a human operator to send and receive, particularly in noisy or fading conditions. Remember that. CW and single sideband are considered weak signal modes because they are more effective than FM at low signal strengths. Remember that when you'll see it again. When I say that, that means they're test questions. Okay. If a single sideband signal can use either upper or lower sideband, which one should you use? Okay, ham radio has standardized on the following conventions. Below 10 megahertz, you use lower sideband. That's 160, 80, 60. Well, 60 is a channelized band. That doesn't count.
It's still, I guess, LSB.
Yeah, I think so, but yeah, I won't say 60. 160, 80, 40,
Yeah.
30. Okay, above 10 megahertz.
Except that 30 doesn't use any AM at all.
Right.
No voice.
Yeah. Above 10 megahertz is upper sideband, and that's 20, 17, 15, 12, 10, 6, all the way up to 1296.
And above.
And above. Okay. Back up. Okay, one exception, which Howard just told you, amateurs are required to use upper sideband. Okay, we just answered that question. Okay, we found the answer on 60 meters.
Okay.
And if you buy an older radio, it probably will not work on 60 meters.
Yeah, that's true.
Okay, now we get to see where we have to remember those things. What is CW? It is another name for Morse code. I am not going to go over the wrong answers. Okay. Which of the following is a form of amplitude modulation? Single sideband. Okay. Which type of modulation is commonly used for VHF packet radio transmission? Okay, the key word there is VHF. What do you do on VHF? FM or phase modulation? Frequency modulation, phase modulation. Okay, which type of modulation is commonly used for VHF and UHF voice repeaters? Frequency modulation or phase modulation? That's the same answer asked from two different directions. Okay. Which of the following is a disadvantage of FM compared with single sideband? Only one signal can be received at a time. Okay. Which type of voice mode is often used for long distance, weak signal, remember that word, contacts on the VHF and UHF bands? Single sideband. Okay, which of the following types of signal has the narrowest bandwidth? CW. It's one tone. Which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications? Which of the sidebands? Upper. Remember, 10 meters is above 10 megahertz. What, 28.0 to 28.97 or something like that is your actual band that you work in. Or no, it's 29 something.
Yeah, it stops at 30.
Yeah, stops at 30. And as technicians, you have some voice privileges in the bottom end of that 10-meter band. Don't forget that.
Yeah, especially at this time in the sunspot cycle.
Yes. 10 meters. I worked my 49th state the other night and got it confirmed for worked all states on 10 meters. Okay. What is a characteristic of single sideband compared to FM? Single sideband signals have narrower bandwidth. Okay, what is the approximate bandwidth of a typical single sideband voice signal? 3 kilohertz. Okay, what is the approximate bandwidth of a VHF repeater FM voice signal? Between 10 and 15 kilohertz. You've got a chart in your study manual that shows this. This wasn't in the presentation. Oh, I had a college professor tell me, somebody asked, what are we going to learn? He says, everything that's not in the textbook, my lectures, or your notes will be on the final exam. So this is one of those. Next one. What is the approximate bandwidth of AM fast scan TV transmissions? About 6 megahertz. You see, we're talking about putting more and more information into that signal is what it amounts to. Okay. What is the approximate bandwidth required to transmit a CW signal? Remember what we said about CW signals? 150 hertz. Very small. Okay. Transmitters and receivers.
Let me put one thing in here. You cannot tell the difference between a phase modulated and an FM signal.
Right.
You don't know whether your radio is using phase modulation or FM, and I really don't know how to tell the difference.
Well,
without looking at circuitry and stuff like that.
Yeah. And I had to bite my tongue when I was reading this stuff, and I thought, why in the world do they even mention phase modulation? But to me, that's a confusing thing because you never hear any of us talk about our phase modulated radios. I'm not aware that I own one. I may and just don't know it, but all the literature says FM. Okay, transmitters and receivers. Usually all in one box called a transceiver. Gives you control of the frequency and mode. Then we have some very generalized categories. And remember some of these words. Mobile, single sideband, dual band. That means like our 2 meter 440 FM radios. All band, that's a radio that covers like everything from 160 to 10 meters or maybe 6 meters, or that 857 I have, but also cover 2 meters. That you'd call that an all band radio. Multimode, that means that it will do CW, AM, FM.
Sideband?
Well, yeah. I wasn't going to split the pie that way, but if that happens to turn out to be one of the answers, remember it. Okay, handheld or HT. And again, these are just very broad categories because I would consider my handheld to be mobile. I would consider my all-band FT891 as mobile because it's physically small enough to fit under the dash of the car, or at least ways behind the seat or something. The faceplate's removable. So don't get too hung up on exactly what's what. If I had my 1977 Chevrolet Impala, my Corsair 2 would be considered mobile. So, okay, single band mobile, 2 meter, which is a good starter radio. That's the little black things operate on a 13.8 volt DC. They require an external power supply, or you plug it into the cigarette lighter on your car if you still have one. They don't call them cigarette lighters anymore. They call them power ports.
Yeah.
It does require an external antenna. like your table model AM radio, that antenna is inside the box. Can be operated as mobile or base. Yeah. Limited to frequency modulation or FM, and is usually either 2 meter or 70 centimeter. That's what we call 440. We tend to mix band wavelengths and frequencies up just to confuse new people. I have a 2 meter 440 handheld radio. I should say I have a 2 meter 70 centimeter handheld radio to be technically correct. Okay. Up to approximately 50 watts output. I don't think I want to be holding a handheld that's putting out 50 watts. At least ways not for very long. My 5-watt old Icom radio on 5 watts, if I talked over about 30 seconds, the belt clip, which you had in your hand, was the heat sink for the finals. You put the radio down real quick. But your mobile radio, 50, some of them, if you look around, you can find some 70 and 80 watt ones, but most of them are up to 50, and they can be cut down in power to 5 watts, most of them. Okay, next one. Again, they're typically VHF and UHF. VHF stands for very high frequency, and UHF stands for ultra high frequency.
Harry.
Yes, sir.
You might want to explain to them what a heat sink is. Because all of us talk about it, you might want to explain it.
Okay, the heat sink is the thing that keeps your output transistors from overheating and creating that blue smoke that we try and keep inside the box. As you're running power through that thing, it gets warm. And that heat sink is just a way of transferring that heat away. Some of the smaller, the newer radios with 5 watts, the frame of the radio, which is inside the box, would be the heat sink. And it just absorbs that because you're typically not hearing, you're not talking continuously on that kind of radio. The heat sink on the back of my 7850 over here is an aluminum block that's it's the width and the height of the radio and sticks out about 1 inch in the back, and it's got fins on it.
Harry,
yeah.
Here's my 2900 that has
okay, there you go. That's what I was looking for. Yeah.
Built-in heat sink.
Yeah.
All this is a heat sink, and this does get hot. And what this does is keep the internal components from getting too hot.
Yeah.
But when you talk on running 75 watts for a period of time, this definitely gets hot. So that's a heat sink.
Yep, that's a heat sink. So yeah, that's not going to be a question on your test, so don't worry about it. But it's still something that you're eventually going to need to know something about. Okay, next one up. Dual band mobile radios, same as the single band, except that you can run it on 2 bands. This little thing here is a dual band mobile radio because I can carry it around with me, and it does 2 bands. Okay, some of them include 6 meters. Some of them have all the 220 megahertz band or 1.25 meters, or they can go up to 1.2 gigahertz. You read the literature when you get ready to buy it and pick out what you think you want to use.
And you kind of need to look around and see what everybody else is using, because if you had a 1.2 gigahertz expensive handheld around here, you might be greatly disappointed in how many people you can talk to.
Like you can look in the mirror and talk to yourself is about what it comes down to around here now. And again, I think Randy may say this later, around here, the 222 megahertz is not used very much, but if you get into the Charlotte area, I think it's used a lot. So yeah, look around and see what other people are using in your neighborhood. Okay, next one. Might have separate antenna connections for each band or a single connection for a dual band. That's what you see here is one antenna. Okay, if this radio were doing 6 meters, it might have two. The Yaesu FT857 that I had two antenna connectors on the back, one of them for 160 to 6 and the other one for 2 meters. Those bands are so much separated that the equipment inside the radio is different. It just handles different frequency ranges. Okay. Again, up to about 50 watts. And again, the typical frequencies are VHF and UHF. Multi-mode. Okay. It says nearly all rigs are multi-mode. So let's go on and see what the next line is.
HF rigs, Harry.
Yeah, nearly all HF. Yeah, you're right. The handhelds aren't. VHF multimode operates on FM plus AM, single sideband, and CW. Remember I told you to remember that weak signal word? Required for weak signal operation on VHF and UHF because you may be running 2 meter single sideband as opposed to FM. Okay, more features add complexity and cost. Yeah, they do. More flexibility will allow you to explore new modes as you gain experience, and as you upgrade your license, you get more privileges. Okay, multi-band covers many bands, and they usually mean that it covers HF plus VHF/UHF. See the next one. It also covers all the modes. And they're frequently 100 watts. There are a couple out there that'll put out 200, but 100 watts. There are some bands that have some power limitations on them. Okay, next one. Okay, larger units have internal power supplies. I'm not aware of any that we would normally be in contact with that are new, that have an internal power supply. Smaller units need external power supplies, and that was that top box I showed you on my station. Some have built-in tuners. Okay. Handheld, small handheld FM unit. Yeah. If you're going to hold it in your hand, it's going to be small. Can be the single band or dual band, or limited to usually 5 watts or less, although there's some running around out there now that advertise that they'll put out 8 watts. And I've got one back here that puts out 6 according to the box. The battery is usually part of the radio, and the antenna, although it comes off the radio, you get all that in the box when you buy it. Okay, yeah, it's often purchased as a starter rig, but it has low power, which limits your range, and primarily as a starter rig, just because it's the least expensive of what you can buy. Single, dual, multi-band versions exist, and again, the more bells and whistles, the more dollar signs go with that. Some can receive outside the ham band, such as aircraft, commercial, FM broadcast, etc. Most of the Chinese radios, and this one I have here is an Oshing, If I could remember which button to press, I could listen to FM, or I can get the weather. I don't know that it will go down to the aircraft frequency, and I don't think that's FM anyway, but you can get commercial broadcast and the normal 2-meter, 70-centimeter ham bands. And he's even got a flashlight on it if I press the right button too. Okay. Guess what? Your handheld radio is very, very portable and is self-contained. Okay. Internal microphone and speaker. Yep. If you look on the front of that radio, you see a little tiny hole. That is the microphone. Don't let it get stopped up with dirt. Have a rubber duck antenna. My personal opinion of a rubber duck antenna is a good thing to put over the hole in the top of your radio to keep the dirt and water out of it. They do work. They're battery powered, although with this Oshing, I have an adapter that will replace the battery that I can plug into the car. But that's still battery powered if the car motor's not running. But yeah, they're most of them are battery powered. Extra battery packs, AA cell packs are useful in emergencies. With this Oshing, it's about 10 years old. The factory battery has died. I didn't want to spend $40 on a new one, so I bought an $8 battery pack and filled it full of AA's. Drop-in chargers, and they charge pretty fast. The lithium-ion batteries with a charger that has got some intelligence built into it, you can recharge it pretty quick. Extended antenna. You can buy this antenna on my radio as an add-on, or it's longer than the rubber duck, and there's some even longer ones. Keep going. You can get an external microphone and speaker, which I do have. Sometimes it's nice to have the thing clipped onto your backpack or your belt, and you have an earphone and microphone hanging off your head, and you don't have to worry about the radio getting in the way. Next up, headset. Yeah, just said that. Keep going. That's the 911 repeater that's the 911 repeater just told us who it was. Take a look at that. I'm not going to spend time on it, but if you're trying to decide what you want to do, then look for the easy and the medium spots. If you're brand new, I would stay away from difficult, and down there where it says programming, challenging, Randy up there, there's a teenager inside of Randy somewhere, because he can sit and program a Baofeng with 2 thumbs, just like the kids do their game plans. So, but just to take a look at that and, pick what you think is going to work best for you. And then you get down to that last one, cost. That's probably should have been at the top of the list. How deep your pocket is going to determine at least what your upper limit is. You may decide I really don't need that much radio. Like you don't need a $500 handheld radio right now. A $40 mic will work just fine. As you get more experience and do more things, that $500 handheld radio may be the better radio, but that's the decision. Bring the next one up. Let's get by this one. Okay, there are some samples. You see the dual band radio over there. It's set up for, I guess, okay, that's all right. That is the 2-meter or 70-centimeter, except that's 439.640 megahertz. But anyway, and you see that the faceplate on that thing is separated from the body. they'll sell you about a 10-foot long cable, and you could mount the radio part of that in the trunk of your car and hang that display from the air vents in the dash of your car. You have to watch out and see where the microphone plugs in. Some of them, they plug into that faceplate, and some of them you have to have a long microphone extension cord too. There's the handheld, and then they've got a Kenwood, I can't read that number. That's a 590. That's their latest radio, I think, in the multi-band. You can see it does a lot of things. You've got a waterfall display. You've got a whole bunch of buttons, and usually buttons replace a knob, or in the case of my 7300, I punch a button called menu, and then I start touching the screen. Different companies have different ways of doing things. For that multi-band radio, brand new, I'm going to throw a number out here of $1,500 as a beginning for a brand new one. And what's that one that will do everything, Howard? Is it $43,000 or is it $17,000?
Well, now you say that, but right now the 7300 is on sale for about $1,000.
And that is, I paid $12 for mine when I bought it 4 years ago.
But and it is probably a really good starter radio. I mean, it really good starter radio.
It will do 10 million things, of which I know 4. But that's what I do. It will. Howard got me the other day. He's got a real nice radio that works on the UHF and VHF, and he couldn't find anybody on 1296. No, it wasn't 1296. What was it? What did
It was 1296, and I haven't found too many on 440.
Yeah, but I took my 7300 and sent him, and I was a 10-meter FM. I've never done that. I don't do it, but he wanted to know if his radio worked.
Yeah.
And I just had to go touch my screen and find the right place to touch, and it did it. So yeah, that again, when you're looking, look real hard. And 7300, that 590.
Now, and the expensive one is, and the ICOM is 7851, and it may be down to $12,500, and it may be up at 14.5 still. I don't know.
So, depending on how deep your pocket is, but in my mind, what I do, that 7300 will do 100 times more than what I do. But at $1,000, that's just for the radio. You got to throw in another, I'm going to say $300 to $500 for a power supply and a tuner. Which we haven't talked about tuners yet, and we won't in this class, but except to show you that I've got one. Next one up. Okay, 2 functions common to all radios are control of frequency and mode. Remember those words. Amateurs can use many different modes. Most other radio services are restricted to a single mode. If you own that AM broadcast station, that's all you can do. You can't do FM. And if you own the FM station, you can't do AM. Not on that station. Okay, for multiband radios, begin by selecting the band. Okay, and then you select a frequency within the band, and that's called tuning. That's turning the big knob in the middle or on the right, usually. It uses a variable frequency oscillator or VFO. That's one way, or turning the knob, or some radios have a keypad. You can punch in the frequency on the front of the radio. Depends on the radio. Okay, there are memory channels. I like memory channels because once you have programmed that memory channel, When you go back to that channel, it selects the band, it selects the frequency, it selects the mode just by touching that one button. And if most of your UHF and VHF radios, if you've got 2 or 3 repeaters that you like to get on regularly, you're going to probably program them into a memory mode. Okay, after you selected the band and the frequency, then you have to tell it, am I going to do single sideband, AM, FM, CW, or data? Okay, bring the next one up. Transmitter functions, okay. We talked about receiving. Transmitter output power. In the HF rigs and radios using AM, single sideband, and CW, that output power is controlled by an RF power control knob. If you look on the front of your radio, you're going to find something labeled RF. That's controlling how much power your radio is putting out. How we doing on time, Howard?
It's right now 8 o'clock. Yep.
I saw what time it is, but I haven't kept track of where we are in this presentation.
We're on slide 40 of 108 slides.
Oh, okay. I'll talk faster. FM handheld and mobile radios have selectable fixed power levels. I said earlier on my radio, it goes 5, 20, and 50 watts. The 7300, I've got a knob that I can change.
Are you going, Harry?
Change it from 5 to 100 watts and anything in between.
Okay.
Nope. Microphone gain controls the level of speech audio on single sideband transmitters. FM transmitters usually have a fixed microphone gain. Okay, next. Switching between receive and transmit on voice. Manually, we use that push to talk button. It's either on the side of the mic or the radio. There is an automatic thing called voice operated transmitter, or what you'll see on your radio is VOX. We say Vox. Then on CW, you use a key or an electronic keyer, which is faster than manual. It generates the dots and dashes, and you tell it which one. Next. This is really important when you get started. Use a dummy load to avoid interfering with other stations while you're adjusting your transmitter. And this is a dummy load is a very heavy resistor that can absorb and dissipate output power. Next one. Okay. Spurious signals. Okay. Excessive modulation results in distortion of transmitted speech. That's screaming in the microphone, turning the microphone gain up too high. Spurious outputs on adjacent frequencies is called splatter. Overmodulated FM signals has excessive deviation, and you people say, oh, you're over deviating. It's usually caused by speaking too loudly into the microphone. Okay. Overmodulation of an AM or single sideband signal is caused by speaking too loudly or by setting the microphone gain or speech compression too high. Okay, receiver functions. AF gain, it's the old volume control knob. That sets the speaker in the headphones listening level. RF gain adjusts the sensitivity of the receiver to incoming signals. Remember the difference. RF and transmitter is how much power it's putting out. RF gain is what you're telling your radio, how hard do I want to listen? It adjusts the sensitivity to the incoming signal. Okay, next one. Automatic gain control, or AGC, adjusts the sensitivity to keep the output volume constant for both weak and strong signals. You can read a little bit more in your manual about that. Next one. Squelch mutes the receiver's audio output when no signal is present. It eliminates continuous noise. That's the hissing sound that you hear. Many transceivers have a monitor switch that temporarily opens the squelch to hear weak signals. I think your book talks a little bit more about that too. Selectivity and sensitivity. Receivers are compared on the basis of two primary characteristics, sensitivity and selectivity. Okay? Sensitivity determines receivers' ability to detect signals, and it's specified as a minimum detectable signal level in microvolts. That's not much of a volt. A preamplifier or a preamp is used to boost the sensitivity. Selectivity is the ability of the receiver to discriminate between two signals. High selectivity means that a receiver can operate properly even in the presence of strong signals on nearby frequencies. Okay, filtering and tuning. A receiver rejects unwanted signals through the use of filters. Signals then pass through filters narrow enough, smaller bandwidth to reject all but the desired signals. Wide filters around 2.4 kilohertz are used for SSB signal reception. Narrow filters around 500 hertz are used for CW and data mode. Multiple filters allow you to reduce noise or interference by selecting a filter that is just wide enough in bandwidth to pass the desired signal. Okay, receiver incremental tuning, or RIT, which is also called a clarifier, is a fine-tuning control used for both single sideband and CW. It allows you to tune in a station that is slightly off frequency or to adjust the pitch of an operator's voice that seems too high or too low. VHF and UHF power amplifiers, okay? RF power amplifiers can be used to increase the output power by a factor of 5 or more. Many VHF and UHF power amplifiers can be used on all modes, including single sideband and CW. The amplifier will switch between modes. Okay, caution number 1 was be sure your antenna is capable of handling the higher power. Okay, and then be sure that you learn about RF exposure. Transverters. By using mixers, it is possible to convert an entire transceiver to operate on a different band. Mixers are part of equipment called a transverter. A receiving converter mixer shifts input signals to the desired band where they are received as regular signals by the transceiver. Okay, transverter allows one main transceiver to be used on one or more new bands. Basically, it takes the band that you want to hear and moves it to a frequency that your receiver will receive on. Okay, now we get to the fun part again. Which of the following can be used to enter a transceiver's operating frequency? Keypad or VFO knob? What is a way to enable quick access to a favorite frequency or channel on your transceiver? Store it in a memory channel. What is an electronic keyer? It is a device that assists in manual sending of Morse code. It makes perfect dots and dashes. Okay. What is the function of the receiver's push-to-talk input? It switches the transceiver from receive to transmit when grounded. Remember that, when grounded. Okay, what is the primary purpose of a dummy load? That prevents you from transmitting a signal over the air when making tests. Okay, what does a dummy load consist of? A dummy, yeah.
An old busload of CBers.
Yep. A non-inductive, and I don't know if you read that word non-inductive in your manual or not. We didn't say it that way in the presentation. A non-inductive resistor mounted in a heat sink. A resistor could be made out of a coil of metal. That turns it into an antenna. Okay, next one. What could cause your FM transmission audio to be distorted on voice peaks? You're talking too loudly. Okay. What is the effect of excessive microphone gain on single sideband transmissions? Okay. Distorted transmitted audio. Okay. What can you do if you are told your FM handheld or mobile transceiver is over deviating? Talk further away from the microphone. What is the purpose of a squelch function? It mutes the receiver's audio when a signal is not present. If that didn't work, you hear a constant hiss, almost like tinnitus. Okay. How is squelch adjusted so that a weak FM signal can be heard? Set the squelch threshold so that receiver output audio is on all the time. That means you're going to hear the hiss too. Okay. What term describes the ability of a receiver to detect the presence of a signal? Let's try sensitivity. Okay. What term describes the ability of a receiver to discriminate between multiple signals? And that one is selectivity. Where is an RF preamplifier installed? Between the antenna and the receiver. I think that's one you had to figure out for yourself. Okay, which of the following controls could be used if the voice pitch of a single sideband signal returning to your CQ call seems too high or too low? The RIT or clarifier. What is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? Okay, it permits noise or interference reduction by selecting a bandwidth matching the mode. Okay. Which of the following receiver filter bandwidth provides the best signal to noise ratio for SSB reception? And that is 2400 hertz. What is the results of tuning an FM receiver above or below a signal's frequency? It's going to be distorted. What is the function of the single sideband CW-FM switch on a VHF power amplifier? It sets the amplifier for proper operation in the selected mode. What device increases the transmitted power, output power of a transceiver? An RF power amplifier. What device converts the RF input and output of a transceiver to another band? That's the transverter. Okay, digital communications. Why do we want to use digital modes? Okay. Special codes and characters embedded in the stream of data allow the receiving modem to detect and correct errors. Amateurs have developed or adapted techniques for exchanging digital data by transforming the ones and zeros of data into tones that are in the same frequency range as the human voice. Okay, amateur digital modes. Different combinations of protocols, codes, and modulations such as single sideband or FM are used to create digital modes. Popular HF digital modes. You have RTTY. When you hear us say, oh, he's running RTTY, that's RTTY, radio teletype. PSK31, which is, that stands for, used to stand for phase shift keying, and the 31, I think, is the bandwidth it takes up. It's keyboard to keyboard. You can sit at your computer and exchange conversations back and forth, but you're typing while you do it. FT8 and WSPR, you hear us talking about the whisper modes. That's their weak signal modes. And we're talking in some cases of milliwatts. And then there's Pactor and Winmore, which are used for WinLink messaging. And I think WinLink is an email way over HF radio. Okay, popular VHF and UHF digital modes are packet radio. You can read about that. WinLink, they call that B2F protocol for WinLink, JT65 for moon bounce, MSK 144 for scatter pass. And here's one you need to remember. IEEE 802.11 Wi-Fi, adapted for amateur use on microwave bands. And I think you need to remember that because you'll see it again and you can read more about it in your book. Okay. Then you have the popular voice modes or digital modes is AOR and FreeDV. I think these are tied to some software and they work on HF. And then there's D-Star, System Fusion, which is C4FM, which is a digital mode, DMR, and P25. P25 is Motorola's digital system, and they're used on VHF and UHF. Okay, packet and packet networks. On VHF and UHF, the most common digital mode is packet radio. Data characters are transmitted in groups called packets. Frequency shift keying is used to transmit individual characters, FSK. Each packet consists of a header, data, and a checksum. If an error is detected, the receiver automatically request the packet be retransmitted until the data is properly received. And that's called automatic repeat request, or ARQ. Keyboard to keyboard. Digital modes that are designed for real-time person-to-person communications are called keyboard to keyboard modes. Most popular on the HF bands. And most are generated by computer software using a sound card and an interface to a transceiver's audio input and output. Radio teletype is the oldest. The most popular, which I think that's changed, but PSK 31, or phase shift keying at 31 baud, works very well in noisy conditions. It occupies a very, very small space on the frequency. That's why it works so well. Okay, APRS, you'll hear us say that, or some people say APRS, Automatic Packet Reporting System. Okay, it uses packet radio to transmit the position information from a moving or portable station. Basically, a packet radio station combined with a global positioning system, or GPS receiver, can transmit GPS position data. Can also transmit weather information and short text messages. A common public service for APRS is to provide maps of station locations while they are providing real-time tactical communications. Okay? That's what it looks like. You have, says data interfaces are connected between the transceiver's audio inputs and outputs. That's that audio interface box down there. Your computer's data connection is USB or a COM port. And then you have a TNC, or, as some of you heard me say earlier, an MPC, a multiple protocol controller. Just so you know what a multiple protocol controller is, there is one. Little black box. Okay. And what these do is they convert the data and audio between the radio and the computer. What you're transmitting is the signal that's got the data on it. You need a way to take that signal and turn it into something that you can see or hear. Okay, the audio interface isolates the computer sound card from the radio to prevent hum. Okay, next one up. Again, there's my station. That little white box up on the top is the MPC. And you can see down on the side, the black cord is the audio cable, and the white one behind it is the USB cable. Okay, next slide. That's what it looks like on the back. Now, if you remember all those lines on that sketch, that's what it turns into real life. The MPC box on the top, I like lights, so I powered this one, but you have the two cables that connect to the PC. That takes the sound to the PC. The cables on the right connect the audio out of the radio and the push-to-talk function. And then all the rest of the cables are part of what make the radio work. We won't go into the rest of it, but that's what the back of it looks like. Okay. We're going to set up for digital modes. A popular example of a sound card mode is FT8. Okay. If you use a sound card mode, you may need a digital communications interface to supply the push-to-talk. Remember I said my little MPC box had that in it? Oh, and that's to key the transmitter. Okay, next. There it is again. Okay, this is a gateway. And a gateway is a way that you can connect your radio to the internet. And that works for APRS and WinLink, okay? The gateway shown in that previous figure is a special kind of digital station that provides a connection to the internet via amateur radio, okay? Most gateways are set up to forward messages. All the rules and regulations about commercial and business-related messages and communications apply to internet gateways. Follow the amateur radio rules, and we'll do that in lesson 8. Fun and games again. Which of the following is a digital communication mode? All of them. Packet. I told you you'd see IEEE 802.11 and FTA. They're all correct. It's D. Okay, which of the following best describes an amateur radio mesh network? I hope in your book that they talked about mesh networks a little bit. Okay, an amateur radio station based data network using commercial Wi-Fi equipment with modified firmware. Those little blue Linksys boxes that you bought 10 years ago to give you wireless and hook two or three other computers together wirelessly can be modified with changed firmware, and it's what, 2.4 gigahertz, Howard?
Yeah, I believe so.
And you can station those things 1,000 feet or so apart and run your race with it.
And what the software does is change it to where it operates on amateur radio frequencies.
Yeah. Okay, that is back up. Let's look at the answer to that question. That was number A, an amateur-based data network using commercial Wi-Fi equipment with modified firmware. Remember some of those words. You're going to see them again. Okay. Which of the following operating activities is supported by digital mode software in the WSJTX software suite? They talked about that in your book. All of them. Earth, Moon, Earth, weak signal, propagation beacons, that was Whisper, and meteor scatter, and some others. What is FT8? It is a digital mode capable of low signal to noise operation. I think it's the right answer.
I'm sorry.
Yep, I got it right. How about that?
And the FT stands for Frank Taylor.
Yeah. Okay, which of the following is included in packet audio radio transmissions? All of them are correct. You have error correction, and this takes place in microseconds. You'll never, if you're running packet radio, you will never see this happen. You may have the software record it later, but it's very fast. Checksum, you've seen that when you've downloaded some of the Linux software, they will give you that checksum number. That's a tool you use to make sure that when you downloaded the software, it downloaded completely and correctly. This is the same thing here.
And it is a handheld, a holdover from the days when you were transmitting messages either by voice or CW that were to be forwarded to someone else. They would have a checksum at the end, a word count or a letter count, so that you would know that you had gotten it right.
Yeah, yeah. Okay. All of those answers are correct. What is an ARQ transmission system? C, error correction, method in which the receiving station detects errors and sends a request for retransmission. As I said, that happens very fast. Okay, what does the abbreviation PSK mean? That's phase shift keying. Okay. What kind of data can be transmitted by APRS? All of them. GPS, text messages, and weather. That was one of our slides. All are correct. Which of the following is an application of APRS? Providing real-time tactical digital communication in conjunction with a map showing the location of stations. The software will be a map and you'll see little dots moving around. That's the people with the radios that are doing this. You'll know where they're at. Okay, how are the transceiver audio input and output connected in a station configured to operate using FT8? To the audio input and output of a computer running WSJTX software. My answer is that jumble of wires behind my radio. Okay, what signals are used in a computer radio interface for digital mode operation? Receive audio, transmit audio, and transmitter keying. C. Which of the following connections? Somebody's got their tenses wrong. Anyway, which of the following auto connections is made between a computer, I guess that is correct, and a transmitter to use computer software when operating digital modes? Computer line in to transceiver speaker connector. Line in, I hope that's in your manual because it's not in these slides. That's the connection on the back of your computer, usually a little blue one, I think. Maybe, and it may be pink in some computers. Okay, what is the amateur radio station? What is an amateur radio station? Connects other amateur radio stations to the internet. That's a gateway. Okay, power supplies. We're nearing the end, folks. A solid power source is important for a clean, noise-free transmitted signal and better reception. Okay, power supply converts the AC input power, what comes out of the wall, to DC current for the radio equipment. Two main advantages, or two main ratings you want to look at. Output voltage needs to be capable of 13.8, and the amount of current it can supply continuously. Okay. Radios that operate from a 12-volt supply may actually work best at a slightly higher voltage of 13.8, typical of a vehicle power system with the engine running. Okay. If you don't know the amount of current a radio can draw, divide the output power by the input voltage. You remember Rick's little circle? Put your finger over what you want to know, and what's left is what you got to work with. If you don't know the amount of current to draw, divide the output power by the input voltage, then double the resulting current value and round up to the nearest amp. Generally speaking, 8 amps will work a 50-watt mobile rig. I think you need to remember that. Keep going. Okay, a supply's output voltage changes as the amount of output current with the amount of output current. A regulated supply, remember that word, uses a regulator circuit to minimize the amount of voltage change. If more than just one piece of equipment is hooked to the supply and turned on at the same time, add all the equipment maximum currents together to find out how much you need. Mobile power wiring. Radio equipment can draw large currents when transmitting. If the wire's too thin, its resistance, the R, will create a voltage drop of current times resistance. The resulting lower voltage at the radio causes it to operate improperly, maybe distorting your output signal or creating interference. It can do one or both. General guidelines for mobile wiring. And these are important to remember. The fuse should be present in both the positive and negative leads of your radio. And I think your book talks about the why. Connect the radio's negative lead to the negative battery terminal or where the battery ground lead is connected to the vehicle body. Be careful when you do that. Use grommets or sleeves to protect wiring from chafing or rubbing on exposed metal. That's really important. I know a person who had to buy a new interior for his car because his stereo lead shorted out and set the inside of his car on fire. Rubbed against the seat bracket. Don't assume all metal is connected to the battery's negative terminal. If you had a Saturn 100, that was a fiberglass car. You couldn't screw a wire to anything on the body of that car because it wasn't metal. Okay, batteries. Batteries are made up of one or more cells. How long will a fully charged battery power your equipment? Okay, in the next slide, we're going to look at a table. Divide the energy rating in ampere hours by the total current needs of the equipment. And remember to use the average current draw for transceivers since you will not be transmitting all the time. Storage batteries are often used as an emergency power source, and they have some cautions. One is don't drink the battery acid. Contain strong acids that can be hazardous if spilled or allowed to leak. Number two is they can release or vent flammable hydrogen gas that cause an explosion. I think that can happen on both charge and discharge, but mostly on charge. Accidentally short-circuiting a storage battery with a tool, that means you dropped your wrench or screwdriver across the battery terminals, can easily cause a fire or damage the battery. And that's just if you're lucky. Okay. Here's all the different kinds of batteries. We have AAAs, AA's that are disposable. That's your ordinary alkaline battery. You have AA's that are carbon zinc. They're also disposable. You have nickel cadmium. We say NiCads. They are rechargeable. The thing to remember here is their fully charged voltage is 1.2 volts, not 1.5 volts. Then you have nickel metal hydride rechargeable batteries. They're also 1.2 volts. Then we get down to disposable alkalines of C, D, 9 volt. They have different energy ratings over there. That D battery's got 14,000 milliamp hours, whereas that AA has got 1,100 milliamp hours. They'll both run your radio just for not as long. Okay, a 9-volt NiCad battery, which is rechargeable. And it's interesting that the 9-volt batteries, whether they're disposable or rechargeable, are 9 volts. Let's go on down to the coin cells. They're lithium disposable, 3 to 3.3 volts. They don't put out a whole lot of energy, but that's what's in your watch. It's what keeps your computer memory alive. Then you have the rechargeable battery packs, which is going to be what runs your handheld radio. You may carry one around to recharge your cell phone on a trip. They're lithium-ion batteries. They are rechargeable, and they run 3.3 to 3.6 volts per cell. And be careful, because some of them are the same size as AA's. Lead acid storage batteries are rechargeable. They're 2 volts per cell. And depending on the size of the battery, it'll tell you how many cells they put together. Okay, let's move on. There are some questions out of this, though. We're going to see them. Okay. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? Okay. 50 watts. Remember how many amps they told you a minimum would be good for? You don't see that on this chart, but it's the next bigger one. D, 13.8 volts at 12 amps. Okay. What type of circuit controls the amount of voltage from a power supply? It's a regulator. Okay. Why are short heavy gauge wires used for transceivers' DC power connections? You want to minimize the voltage drop when you are transmitting. Okay. Where should the negative power return of a mobile transceiver be connected to a vehicle? At the 12-volt battery chassis ground. Okay. What hazard is caused by charging or discharging a battery too quickly? Overheating or outgassing? I don't think you saw outgassing in our slide. Okay. What can be determined? How can you determine the length of time that equipment can be powered from a battery? Divide the battery ampere hour rating by the average current draw of the equipment. B. Okay, which of the following battery chemistries is rechargeable? I think it's all of the above. Another correct answer. It's 2 questions I would have gotten right on the test. Keep going. Okay, which of the following battery chemistries is not rechargeable? That's the carbon zinc. You can try and recharge them, and you read all kind of cute ways to make them work longer, but my advice is don't try it. Okay, and guess what? We've got 17 minutes of extra time. Howard, what are we going to do with it?
Well, let's start out with questions.
You folks got all of that, right? Just remember, when you're looking at these questions, like, you probably will not be asked both questions on which is rechargeable and which isn't. You'll probably only be asked one. You just don't know which one until you get the test. And then they snuck in a couple in there like that power supply rating. They told you in the slide presentation 8 amps. They didn't offer you that answer in the question pool, so you have to think a little bit and say, well, if they told me 8 amps, 12 amps is probably going to be good enough, and 4 amps is half enough. So you got to think a little bit.
All right, I have a question. It's kind of tangential, but reading the band plan as well as listening to some people talk online, when they say phone, is that synonymous with voice?
Yes. After Howard shows you this, I'll muddy your water a little bit more. but you can forget it because it won't be on the test. I think phone probably came about because the very first microphone with the old carbon microphone in a telephone handset.
Okay.
You got to unmute it, Howard.
No, I muted it on purpose.
Oh, okay.
You're talking. I was just going to say what we're looking at there is the AM broadcast band, and every one of those is a different station. And you can see the carrier wave and modulation on them.
Would you say that, looking in that upper left-hand screen, that those stations might be on the bare edge of interfering with each other, except when the FCC assigns frequencies, they look at that?
Harry,
Yes.
the term phone, I think, comes from the word homophone.
Okay. Yeah. Yeah, you're correct. Now, where that comes from, I'm not sure.
Well, I think that covers all the communication end of it.
Well, and I'll muddy the water a little bit in that single sideband is phone. The digital modes that we talked about using a computer sound card generate, they say they turn the zeros and the ones into tones that can be transmitted. Those tones are phone, and they're transmitted single sideband. All of them, and by convention, upper sideband. Even on 160 meters is upper sideband. And if you listen to one of those signals, you're going to hear each of those tones has got information in it, and your computer software hears those tones. And I'm not going to tell you any more about that, because then I might be telling you more than I know. The JT65 was for Joe Taylor, Nobel Prize winner, astrophysicist who was interested in amateur radio. And what he really wanted, what he really got him turned on was Earth, Moon, Earth. You send a signal to the moon, you got two problems there. Number one, how far, well, actually three, how far away it is. Number two, is shaped the wrong way to focus a signal back. And thirdly, it's not a very smooth surface. So you send megawatts up and get milliwatts back, and his software will let your radio can hear that signal. You can't hear it with your ear, but your radio can hear it, and send it to the computer, and the computer can decode it, and you can put information in there.
And if you want to hear it on the FT8,
yeah,
it is.
Now that's not one signal.
And there's what the audio looks like of it.
Yeah.
And that's probably 50 signals.
Yeah. I know on my screen, when I first started doing JT65, I would see 3 or 4 stations decode at once. Today on FT8, I'd have to figure out how to turn my screen up long ways to display all the signals that are coming in, because I'll have like 18 signals coming in, and then it'll jump up to the last 6 that just came in at decoded. And we all have our radio set on almost the same frequency, but because of the way that software works, everybody starts at a different place so that you don't interfere with each other that much. Now, when we talked about over-modulating your radio by having your gain turned up or something like that, you do have to be careful, because if you have if you drive your radio too hard, we haven't talked about any of this, but that's part of that. You had your mic gain set too high or your compression set too high. Basically, it's like you're screaming into the microphone. That signal is distorted enough to where your software won't decode it. And you won't know that because it just won't show up on your screen. You know, it can't take that information and put it into a form that you'll recognize. Now, you can forget all of that. It's not on the test. And again, you can, if I can get this up. Trying to get where you can see the front. That little box is about 3 inches long, 1 inch high, and 1.5 inches deep. Oh.
Let me show you real quick a CW signal.
Yeah, and that's got a sound card in it.
That's not it.
There you go. I could almost copy that.
Yeah, that might be 5 words a minute.
Yeah.
That's nice and slow.
Uh-huh. And that woo 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 you heard was another kind of signal. H-E, what's it, A?
Give me your glass and I'll get you some water.
Thank you.
I don't hear that.
Okay. That's enough for the CW.
Yep.
Anything else you would think we might find?
Not really. One of the things that has changed since they wrote this book is FT8 occupies about 60 to 80% of all of the QSOs.
Got your pills.
Remember I said all?
Yeah.
That includes CW, single sideband, FM. Well, this is according to Club Log, because we're talking about HF. You can leave FM out of that. Oh, I've got 32,000 contacts in my log. Probably 90% are digital, most of them FT8. I had, when I got into digital in about 2013 or 14, somewhere in there, the sunspot cycle had died, and I turned the radio on and tune up and down the bands, and I may hear a voice that I couldn't understand. And then I read an article about how I could take this Tech, which does not have a computer connection of any kind on it, doesn't even have an RS-232. Howard's Omni does. He can rig control that radio. Mine's older than that. And I read an article which helped me build this little box and plug my computer into my 35-year-old radio, and all of a sudden the screen started displaying messages, and I thought I'd gone to heaven because we were back in business again, and I haven't looked back. Oh. And again, like I say, I can't get it focused right, but that little box has a sound card in it. Buy one of these $1.98 dongles and pop the cap off of it, and be real careful how you solder. And there's a little circuit in there that does the push to talk, and it transfers the audio from the radio to the computer, and then from the computer back to the radio. And when the computer sends a signal back to the box. Part of that power is diverted and trips a switching transistor, which grounds the push-to-talk switch. Remember that word grounds. You're going to see it on a question somewhere in there. But it does all of that inside that little box, which I think I've got about $35 worth of parts in this little box. And the most expensive component in this box was the box. Oh, like I say, I think I paid $1.98 for the sound card. The box was about $4. But that's an MPC. Don't let that word throw you. It threw me the first time because I didn't ever use it. But that's all it took to get my 35-year-old radio back on the air and having fun again.
Howard,
Yes.
if you go up to 7.255, there's an HF net going on over there.
Hey, instead of saying ground on that box, you might say return. That might be more clear than saying ground. Electrical return.
Oklahoma. I graduated in 1969 Oklahoma.
Hey, thanks so much, 73.
Yeah, 73. The officer station, go ahead. Kilo 9 again. Okay.
That sounds like a state hunter now.
59 Oregon. My call sign Whiskey 1, Alpha Whiskey Sub 7.
A man in a private plane, money for his legal fees, and he might just be a moron.
Yeah.
Okay,
gentlemen, thank you so much. I need to go though.
Okay.
Have a good night. See you next week.
Good night.
Thank you for everything.
You're welcome. Our pleasure.
Good night, guys.
And I say one more thing I'll show you if you can see that.
A little closer, Harry, maybe.
The other way.
No, it's hard to see.
That is an SDR radio right there.
Well, you hold it farther back, a good bit farther back, Harry. Keep going.
All right, hang on. I'm gonna let you see my junk.
Like I said, beauty's in the eye of the beholder.
Okay.
There you go.
That is an SDR dongle. Oh, they use them in Europe. That's how they get their TV. They have a different signal protocol in Europe than we do in this country. But that thing receives anything from 25 megahertz up to 1750. Okay. 25 megahertz is a little bit above anything but 10 meters. That is a transverter. That little board right there is a transverter. And what it does is it takes the antenna is hooked to this connector right here. And there's an oscillator and a mixer circuit in there. And what it does is it takes this signal and boosts it up to something that this thing can recognize. And then you plug that into your computer and let your software do it, and you get to see what Howard had on the screen. Today, if you want to buy that, I've had this about 10 years, but New Electric will sell you this whole thing for about $70. I didn't pay anywhere close to that when I bought this 10 years ago, but that transverter board now is worth about $45.
I believe that's a converter. It doesn't transmit. It's a converter, down converter, up converter.
Yeah, up converter.
This This is another one of the dongles, if you can see it. And this one is, it's made by AMSAT UK. And it goes down, it may go all the way down in frequency. But they're excellent little broadcast reception receivers that you can use for listening to stuff. I just fell in love with this spectrum analyzer and this Win radio when I first saw it. So I have one.
Yeah. Well, and you can take that little dongle and
you can see pieces of that, but with that one, you can actually see 50 megahertz at one time with that receiver.
Yeah, this thing won't do that because it just wasn't built to do that.
Yeah.
I don't know what my son set up with an SDR, but he has one that he left here at the house that is hooked to a Raspberry Pi and an antenna, and you can see airplanes as they're flying around within about a 200-mile radius.
Yeah.
And then you can use SDRs as well with a different type of antenna to get the satellite weather images.
Yeah.
Well, just remember, all of those signals are really and truly the equivalent of a 0 and a 1. And if you've got the right hardware to get it out of the air and get it into your computer and have the right software there, you got it.
And on one of the local repeaters, they have a slow scan TV net on Sunday night where they transmit pictures, and it may take 10 seconds to see the entire picture. But again, you just took the radio up to the computer and used some software, and they transmit pictures back and forth. And you can do that on HF also.
Yeah.
There are so many different things you can do in amateur radio. Again, I can vouch for the fact that it can keep you interested more than 60 years. I'm working on 61 right now. And we're after 9 o'clock.
Yep.